Welcome everyone. This is a quick rundown on Wilcox signed rank test, which is from Fields Discovering Statistics with R, Chapter 15. So I'll just read that for us real quick. Alright, so our first point is that we need to load our data. That's pretty much always the case. So in this case, I'm going to name my data drug data, and grab drug data. Okay, to confirm that drug data was loaded, tap drug data, you can see the drug data. So this data is separating two groups. One group takes ecstasy, one group takes alcohol, and then we measure the depression on 2 days, Sunday and Wednesday. We can look at the differences between the depression level on Sunday and the depression level on Wednesday for both groups. We can look at the differences between Sunday and Wednesday for just the ecstasy group. Just for the alcohol group, we can also compare ecstasy to alcohol for Sunday and ecstasy to alcohol for Wednesday. There's a lot of possible comparisons. Right now, we're going to just be comparing the same group on Wednesday and on Sunday. So ecstasy on Wednesday versus Sunday, and alcohol on Wednesday versus Sunday. That makes these related variables because it's the same person that was measured on both days. So, as a general rule, the first thing we kind of want to do is to run some descriptives, but since we have 2 days, it's nice to have a change variable. So this bit of code here created a variable named BDI change, which is simply the subtraction between the 2 days. So if I type drug data again, you'll notice that we have this change variable. And by just glancing at this, you can see that alcohol goes down and ecstasy goes up. Now we're going to do the rest of this research or stats to show what is totally readily apparent just right there with that. So we're going to run a quick descriptive statistic because it is always good to do descriptive statistics. In this case, I'm basically saying I want to look at change based off of the drug data. So broke it down, alcohol and ecstasy is separate, and the average change for alcohol was negative 6.3, and the average change for ecstasy was a positive 12.4. We're about to run a test eventually to show that those are substantially different from each other, but that's okay. We don't need to do it right now. So in order to test just the alcohol, we make a subset. So the alcohol data is a subset of all of the drug data where the drug was alcohol. So now that I've done that, I'm going to do the same thing with an ecstasy data set. And now I have 2 data sets, one named alcohol data, one named ecstasy data. If I want to check that again, there we go. And they're just alcohol people, as they should be. Okay, so now that I've done that, I can run my Wilcox test for the alcohol group, which is long and nasty. So I'm creating a model named alcohol model. I'm using a Wilcox test. The data I'm using is the Wednesday's BDI, the Sunday's BDI. Paired is true. That's what makes this a related test, paired being true. It's the difference between this one and the last test we ran. Correct is true, and exact is false. Okay, now that I've done that, I can look at my model and I get a 0.05248. That's really close to significant, but isn't. You have to decide how much you care about our arbitrary 0.05 rule. Alright, I'm doing pretty much the exact same thing for the ecstasy model. That is significant. So we can say alcohol is approaching significance, or we could say, you know, let's just be reasonable, it is significant. We're off by 0.002. And the ecstasy model is significant at a 0.014. Okay, that's the end of that. Now our conclusion from that data would be to say that the depression level on Wednesday is different than the depression level on Sunday for the ecstasy group. We're sure about that. And the depression level on Wednesday is, it appears, different than the amount on Sunday at a 0.052 level, which is not quite 0.05, but that's alright.